Hi, and welcome to Strategy Games in ActionScript 3 from Cartoon Smart and from me, John Nyquist, and Nyquist Art and Logic. For this lesson, we're going to learn how to make a strategy game, but the point of this lesson isn't to be a cookbook to show you how to exactly make this game. It's really my hope is to show you how to use a variety of techniques in your own programming, games or other programming. For example, we're going to cover terrain generation, which is going to use spatial averaging, connected component labeling in order to pick out specific areas of an image. Then we're going to do some A-star path finding. And lastly, we're going to do state machines. And we're going to do not just simple state machines, but we're going to do some object-oriented state machines. And along the way, we'll learn some other techniques dealing with bits and dealing with from low-level stuff like dealing with bits to dealing with design patterns as we develop our program. We're going to use a variety of tools in the development of this. So even if you have only one of the tools, for example, Flash, and I'm assuming that you have Flash, the Flash Professional, I'm also going to show how you can use Flash Builder and FlashDevelop. In my own development, when I'm working on things, I'll often use for ActionScript projects, I'll use FlashDevelop, and in conjunction with that, depending on what I'm doing in the project, I'll switch over to Flash Builder. So I don't really use Flash Professional, FlashDevelop, or Flash Builder in my own development. I don't use them exclusively. I tend to, depending on what I'm doing, is going to depend on which tool I'm in. But if you have only one of those, you'll still be able to do this lesson. Heck, if you really wanted to, you could use the free open source MXML-C compiler and Notepad or some other text editor to create this lesson and create ActionScript projects on your own. I don't do it that way, and I'm really not going to show it in this tutorial, but the option is there. Maybe I'll show one quick little example of it. So let's take a look at our options. And you'll be seeing me switch between these in the course of the course. We have Flash Professional, and we have Flash Builder. You'll see it says Flash Builder up here. JRN1, that's just a named workspace that I made, a perspective, as it's called in Flash Builder. And then also FlashDevelop. FlashDevelop is Windows only, so if you're on a Mac, you would need to use Parallels or VMware Fusion or a tool like that. And there are instructions at the FlashDevelop's website, flashdevelop.org, if you want to use it with your Mac. And this is by far my most favorite way to write ActionScript code, is FlashDevelop. These guys really know how to work with ActionScript. But don't worry, if you only have Flash Professional and you see me typing code in FlashDevelop, it doesn't matter. As long as you set it up the way I'll show it, you'll be fine. So I decided to create this course because I started making a game. And the game is called Might and Merit. And what you'll see as we work on this course is how I laid the foundations of making this game. So let's go ahead and set up our environment to work. What I'm going to do is I'm going to work out of this folder here. And when I create my projects, I'm going to save them both into here, projects. It's one project. But since I'm going to be using FlashDevelop and Flash Builder, fortunately, I can combine them in the same folder. Just as luck would have it, the defaults for where it saves the support folders happen to be different named. So let's go ahead, and I'm going to create a new project. So if we go into the project menu, new project, and it's going to be an AS3 project. If you want to do it with a preloader, you can do that, but just to keep it simple. And you're going to see in the course of this video, I make a lot of decisions for the sake of simplicity, to make it the lesson a little bit shorter. And go ahead and browse to desktop. Pick that folder. Click OK. That's OK. I have my logo in there. And what I'm going to do to start out with is partly to make it simpler for you to see when I'm switching between programs. I'm actually going to, even though I could use the same file for Flash Builder and FlashDevelop, I'm going to make them distinct. So I'm just going to rename this. And then we need to rename this file, because the rule is this file name, left of the period, should be the same name as the class. So we've got our source directory, got a directory for libraries, and then a directory for our binaries. And now let's go over to Flash Builder. Let's do a new ActionScript project. And I don't want it in the default location. I want it there. We're going to be using this SDK. I'll click Next. And I'm just going to accept these defaults. Actually, make our life a little easier here. This one's Flash Builder. Say Finish. Switch to Flash Perspective. I'm going to say no, because I like my own perspective. And a perspective's just a workspace, if you're not familiar with this. Here we go. We've got our source folder, and you can see that for Flash Builder, this is the default application. So when we click Run or Debug, it'll run that one. And when we're in FlashDevelop, you'll see that this one with the green arrow, when you click Run, whether you're going to run for debugging or release, it'll run this one. And the defaults are a little bit different, which is kind of interesting. If you notice that FlashDevelop by default does this little routine. If the stage is not null, it'll call init. Otherwise, it's going to add an event listener, and it's going to wait until it's actually added to the stage to call init. And that's our entry point. So that's kind of nice. So if you were to use this movie, the result of this movie, load it into another file, you could do that. It would work. And in Flash, if you have, let's say we open up a new ActionScript 3 document, you just set your class name for your document class, and that will be, we could set it to one of those that we just created, but I think we'll wait a step, use one of the other files. You'll see in a little bit. But here, I'll go ahead. Actually, I'm going to go back and let's wait a second. So what we can do is, for the Flash users, I'll give you this strategygame.fla. And in it, we'll have a library of our artwork that we'll be using to create this stuff. In fact, it'd probably be good to get this stuff off the stage. So a nice clean timeline. Now, alright, well, one of the first classes we're going to create is the terrain class. But for a long time before we actually get some terrain going, I'm going to show some concepts along the way of working with graphics in Flash. Not only a class called the graphics class, but also working with bits. Because you'll see how that comes in handy as we're developing the terrain generator. So I'm gonna add, first I'm gonna add a new folder, and I'm gonna call it MAM. That's gonna be my package for might and merit. And inside this package, I'm gonna add a new class. And that class is going to be terrain, and it's going to extend from sprite. So if you're working with a different editor right now, this is really all you need right now. Package MAM, import flash.display.sprite, public class train extend sprite, and then public function train. That's our constructor. Now, when you're working with the graphics, every sprite, in fact, every display object, I think you have access to a member called graphics, and that's a graphics object, and it allows us to do some drawing. And we're going to do that to help show some ideas initially. So the first thing I'm going to do is I'm going to loop through, and I'm going to use it to create a grid. So first thing I'm going to do is I'm going to create the rows, and then create the columns. And it's going to be 60 rows by 80 columns. And let's make each one 10 pixels wide. So that way we're going to do 600 by 800. Let's do int. Now our columns are going horizontally, so that's why I'm using X for that. And our rows are going vertically, so that's why I'm using Y for it. And then let's do this. I'm picking a color. So this is actually, if you know from your hexadecimal, this is red, this is green, this is blue, so it'll be a bright RGB green color. So now I'm going to draw a rectangle at the X location, at the Y location, and then the width and the height. For the project, let's go ahead and save it. For FlashDevelop in our project properties, we can set this by, there it's already set by 800 by 600, so that's good, 30 frames per second. In Flash, let's go ahead and set this to we'll set it to 800 by 600. A little later on, I'll change it to 1000 by 600. So I'll give me some room on the right, and 30 frames per second. Now, if we want to, at this point, we could say class is man.terrain and run it. And get an error. So let's go ahead and open that up. So here, now I'm in the Flash Professional IDE, editing the same code that I had open in FlashDevelop. So if you're working in Flash, this is what you're going to be seeing. I'll go ahead and save that. Run it. And we have a nice green, and though we can't tell, this is made up of a bunch of little green squares, not one big green square. If we were in FlashDevelop, here it says the file's been modified because we modified it in Flash. We'll say yes to that. You'll see that there's our change that we made. If we wanted to run it here, we just hit the run button, and the command like Control Enter works in FlashDevelop as well. So if you're used to doing that in Flash, it's the same thing in FlashDevelop. So you can see down here the build started, and we're running, and it's not drawing it in green. Because we're actually not running this class. Now we could run this class, but I'm not going to. What I'm going to do instead is we ran this class. So I'm going to say add child new terrain. Give it a run. And there we go. Same sort of thing. Now, my personal preference when I'm developing this, I like to go into properties here and say play in the external player. So when I run it, pops open in our Flash player. Now, for you folks using Flash Builder, I haven't forgotten you, we'll do something similar here. If you noticed in Flash Builder, I was able to just start typing add child, and it did the completion. That's one of the nice things it does. Really, to get that completion in Flash Builder, you need to type the word this if you wanted to just do it automatically. So this dot add child, and then we'll say new terrain. And we'll give that a run. We'll run it without debugging. And here, Flash Builder is popping open the browser window. Now, I'm really not crazy about running it in the browser window like that when I'm developing, but I might do that for this lesson depending on how often I run it in Flash Builder, because otherwise, here I'll show you. What I usually like to do is under the project properties, go under the ActionScript compiler, and for while I'm developing, I turn off the generate HTML wrapper file. That's okay. And I give it a run. And then, similar to Flash and FlashDevelop, it pops open a window. In order to get it to be the window that we size, we're going to have to put a meta tag in to get it to the dimensions that we want it. Also, every time it pops it open, each time it pops it open, it's going to move it down over. And that might drive me nuts by the end of the lesson, but because I don't want it to move off the recording area. Normally on the screen it's not a big deal because it's not going to move off the screen. It will start back up at the top, but since the recording area is less. So we'll see how that goes. In the meantime, let's go ahead and throw in a meta tag. It's an open bracket there, SWF width equals 1,000. Well, let's say 800 for now, so that's the same. Height equals 600. Background color. We'll just make it white for now. And frame rate. And we'll close our bracket. So now, when we give it a run, we get an error. Let's cancel that. Let's take a look at our problems here. Well, I forgot the parens. Here we go. See how it moved off screen. So now we've got a nice 800 by 600 popping open right in Flash Builder as well. So that'll make me happy. Whether we give it a run here in Flash, Flash is a little bit slower. I don't know if they're using a different compiler, but both FlashDevelop and Flash Builder are using the same compiler, and that's MXML-C. So there we go. We got the starting point in all three environments. All right, and there's of course one other option I mentioned before, is doing it from the command line. I don't do it from the command line normally, actually ever, other than just for play, for fun. But if you want to, I'll show you real quick. Let's go into our source folder. I'm going to do, what you need to do is open up a terminal window if you're on the Mac, or the command prompt if you're on Windows, and navigate to your directory. And an easy way to do that in Windows is shift right click, say open command window here, and then what I'm going to do is I'm going to say mxmlc and main flashbuilder.as, and give it a run. And you'll see it built a SWIF. Now, MXMLC comes with a huge number of switches that you can use to specify where it should put the compiled result and so on, which is one reason I don't want to get into it here. Some people create batch files to automate that, but realistically I prefer to just use with one of the IDEs. Also, if MXMLC doesn't work at your command prompt, then what you probably need is a full path to the compiler, which would be in, depending on how you're set up, like for me, I downloaded the Flex SDK and kept that at my root level, so it's in that folder. And then I just added it to my environment path. But there you go, there's the SWIF. So let's go ahead and make this a little bit more obvious that these are separate things, that these are separate squares. We could, of course, move their X and Y locations over a little bit, but instead what I'm going to do is, let's say, if the row is greater than row 29, so that'd be our 30th row, right? Halfway down. And let's set the color to blue. Give that a run. So there you see, once it got past row 29, it's making a blue split right down the middle. What if we did column? What if column got past 39? There we go. So we've drawn it. We get over here to this column, make it blue. Pretty cool. Well, what if we wanted to make a little noise, visual noise? The way we can do that is by adding random colors. Instead of setting the color specifically, let's set it to a random value. So let's go. In fact, let's just change this here. Instead of the green, we'll say math.random times math.power 2 to the 24th, because that's how many colors we have, right? We have 24-bit color. It's actually 32-bit because of the alpha channel, but that's not really color, is it? So we'll pick a random color between, you know, whatever that range is, 0 and 16 million and something. Give this a run. Undefined method. That's because it's math.power. Math.pow. So you see, we've got the random noise over here. Nothing going on over there. Let's go ahead and comment this out. Give that a run. Now I got a screen of random noise where each of these is 10 by 10. That's pretty cool. It's a good way to get some random color, random noise. We happen to be doing it 10 by 10, but you can do it down to, you know, the pixel level if you wanted to. Now, I wouldn't do it that way with this approach necessarily, where you're drawing a rectangle, because this is like drawing a shape, and there's like a limit, I think, of 65,000 shapes that you can draw. But we'll get into actually how to draw to a bitmap a little bit later, and then you can draw as many times as you want. So here, let's try something different. Let's we'll do a random color, but we'll do it from 0 to 255. If you remember, math.random returns a number from 0 to almost 1, but not including 1. So when it's cast, it'll be cast down to an int implicitly because we're putting it into an int. So this is a float times an int. Really the result is a float, or a number in ActionScript talk. And it'll be cast. When it casts it, it'll truncate it, so it'll chop off anything extra. So the highest number that this equation would ever return would be like 255.99999. And when it's turned into an int, it'll be truncated. And the lowest number it'll return would be 0. So now we're getting a random number between 0 and 255. Now that keeps us all in the blue range. Now let's say we wanted to make this gray. I'm going to create a couple more variables. So the red, here, let me go up a line. When we have a number, let's say, 0x, ff, as I mentioned before, each of these relate to the R, G, and B components. But really, this is just one big number if you were to trace it. So what we want to do is each of these range is a value like from 0 to 255. FF is 255 in hexadecimal. So what we're going to do is try and get that 255 value shifted over so it's here and here as well. And the way we do that is with bit shifting. So we'll say color, and we'll shift it over 16 bits. And then for the G, we'll shift it over 8 bits. And really, we don't have to do this, but just to make it look nice and symmetrical. The red value, or the blue values, are the color that we've been working with. And the resulting color is red plus green plus blue. So now we have a nice grayscale, bit of noise. So where am I going with this? Well, in order to do the terrain generation that I'm seeing in either it being land or sea. So sea is lower in real life than the land. And I'm trying to come up with sort of a mapping based on value, whether you are land or whether you're sea. So you can specify the high points, like the white to be your land and your black to be sea, but there's a certain range that you would say is acceptable for your land. But it's still going to be quite a bit of noise. It's not going to create nice landforms. Even if we did, if we just truncated the light half to green and the dark half to blue. Let's go ahead and do that, in fact. So we'll go ahead and let's comment this out and say color is let's see, is color greater than 127? If so, let's return green. Otherwise, let's return blue. Oops, got an extra colon in there. So you can see, this does not look like land and sea, which is part of the problem. It does create a nice bit of randomness there. But we want to be able to sort of group the areas, soften them, merge them together more, so it's not quite so random, noisy. In my example, here, let me pop open my teaser. You'll see every time I create a new map, it's nice. Gosh, it looks kind of like land masses. So that's what we're going to use some spatial averaging to figure out how to do. In order to smooth the noise out a bit, what we're going to do is we're going to take an average of the heights of each tile that we examine. So for example, with this one, we'd examine all of its neighbors as well as the value here, and then average them. So that's what we're going to do next here. In order to keep track of all of the values, we're going to do this in two passes. The first pass is just going to populate it with the random values, populate an array. So we'll create an array. And then each iteration push a new array on there. And then instead of doing this stuff here, what we're going to do, let's close this off. We really only want to store the color. Let's get rid of that. That would be my Jack Russell Terrier. So here, what we're going to do is get a random value and push it. Terrain, row that we're on, dot push. You know, I noticed I had left that semicolon off the end of a statement. Fortunately, with ActionScript, unlike some languages that look like ActionScript, similar ones, you can use a carriage return and or a semicolon to delimit statements. So you don't have to. I'm used to putting them there. So now, what we're going to do is when we get that average, we're going to iterate over it, so that we're not just going to average it once, but we're going to average it repeatedly. That's how, for my demo, how I get that aging effect. So let's create a variable for that. We'll just set it to 1 for starters. And now we're going to have to go over all the rows and columns again. So we don't have to declare it again, but we do have to reinitialize it to 0. And we're a little bit deeper here, so let's just tab this in. And we need one more curly brace. Now these literals here are starting to get to me. So what I'll do is use one of FlashDevelop's refactoring, Control-Shift-1, say convert to constant, and let's call this the map height. And then let's do that here too, Control-Shift-1. This is the map width. You know, really those are ints. I'm surprised it chose number. I guess it's for Flash, that's the safe option. Let's go ahead down here. This is our map height. This is our map width. That's nice. And then how about this guy too? This is our tile size. Let's go ahead and do that. Tile size. There we go. It's a little bit better. We don't need this code anymore, so we'll get rid of it. Now, what we need to do inside of here is get our averaging. So we'll need a variable for each iteration, var sum. This is going to be a number. Let's start with 0. And each time through the loop, we're going to want to get all the tiles around the current tile. The easy way to do this is with a function. So we'll go ahead and make a function. So we'll say the sum plus equals to, let's get the land height. We'll pass it the terrain, the row that we're on, the column. And here's another refactoring command, Control-Shift-1, generate a, that can be private. And now, the reason we're doing a function is to just keep this little spot cleaner. If you wanted to optimize your code, you'd probably do all this inline. But since we're only doing it at the beginning once, you know, we'll spend those extra milliseconds here. Pi minus 1. Actually, you know, if the row is less than 0, then we're going to go back. So the row is less than 0. It's way up at the top, like we're in the first tile, looking at the first tile. Then we'd go all the way down to the bottom and get that value, which is row 59. So map height is 60. So we want 59, so we'll subtract 1. Else if our row is greater than our map height minus 1, then we'll set row to 0. So if it's 60 or higher, which we could do greater than or equals to if we wanted to, maybe we'll do that. Then we will assign 0, so it wraps back around. So if we're at the very bottom row, we'll do the same thing for column. What we are doing with map width. And we'll return the terrain, row, column. So we call get land height. We're going to do this 8 times. And we're going to do it for the northwest corner, north corner, northeast, west, east, southwest, south, oops, and southeast. Which, to get those values, -1, and the south is all +1. And then west, which is to the left, that's -1. And then east is to the right. And I'm going to do east there. And then lastly, we want to get the tile itself that we're currently on. And what I'm going to do is I'm going to multiply it by 2. So whatever that value is, I'm going to double it. So whatever was in there, whatever that value happened to be, it's going to kind of skew the average. If it was real high, it'll skew it a little bit higher. Real low, it'll skew the average of those sums a little bit lower. So we'll say sum is assigned sum divided by 10.0. And we want it to be 0.0 because right now I want it to have fractional values. And this should look familiar. Color is assigned 0x. There we go. It would help if I declared the color, because I deleted the declaration before, so I'll say var color. Why don't we do this? Why don't we just say var color green, and if it's less than 128, then we'll set it to blue. And we can get rid of this line of code. Set the color. Let's give it a run. Get a few errors here. Oops. There we go. That's first error. Return value must be defined. What do we want from there? It's going to return an int. All right. So that looks wrong. Maybe because we set it to green regardless of let's try that again. Yay! So you can see already with just the first pass of averaging that it's already looking a little bit more like land, although it looks somewhat like Minnesota with 10,000 lakes. So what we can do is we can increase the age here. So let's say 2. Give it a run. All right, now let's double that again. . problem is, the reason it's not changing after the first pass, so let's go back to setting this to 2, is I'm not storing the new color value. I'm preserving it because I'm keeping the same value all the way through. But what I want to do is once I've got this sum, I'm going to go ahead and on that value, so change it. So as we examine each tile, it changes along the way to this new value. And really, since this is a number, gotta be careful here. This should return a number now. Give that a run. Yay, that looks better. So that's 2 passes. So now we'll double that. And we're at age of 4. And that's looking pretty darn good. Well, now that we've got a cool land generator, at least the beginnings of one, let's take a little detour and create some of the grid lines. And I'm going to create a function for that. So after we've drawn all of the shapes here, I'm just going to say add child and then use the refactoring to create that function again. It can be private. What it's going to return is, let's have it return a shape. Since it doesn't have to do anything, shapes are a little less memory intensive than using a sprite or a movie clip. Let's pick a color. So in this case, it can be a constant. And I happen to have picked a nice color here. And then let's go ahead and create the shape itself. And then we're going to tell it to set the line style. And we'll set it to the line color. And we'll do that for now. Now we need to loop through all the rows and all the columns. Less than and height. We want to do move to. That reminds me of the old Macintosh toolbox programming. And whatever row we're on times the tile size, right? So we'll move it down to, let's say, the first, or when it's 1, which would really be the second, that'll move where it's going to start to drawing to 10 at 0, x, 10, y. And then we're going to want this line to go to all the way to the map width. I think map width plus 1, really, right? times tile size. And the y value is the same as it was a moment ago. So that'll draw a line all the way across. And we're going to do a similar thing for the columns. We'll just copy and paste, make that a little quicker. But now we're concerned with the map width. In this case, we want the map height and column. So now we'll draw a bunch of lines vertically. And then lastly, let's do this. Gridlines, blend mode, see, blend, where is it? Blend mode, flash dot display dot blend mode dot multiply. So that'll do multiply on it. I want to say return grid lines. Let's give that a run. All right, we've got our horizontal lines drawing. Now let's check to see what's going on as to why our vertical lines aren't. We've got the column 0 to the map width, and move to, oh, we want to swap this. We want to start out with that, and our row to be 0. And for the height, we want to swap these values also. Right, because this is the x, this is the y. Initially, for drawing vertically, we start at the top and go to the bottom, but we're moving on our x. So we're moving along the columns. That's staying constant. And same thing here. We're moving to the bottom, which that's really not the x location. That's right. Move it over and then move all the way to the bottom. In, these values here, this value and this value, you could store it in a constant instead of recalculating it each time through the loop. But I'll save that as a lesson for the student. So there we go. That looks nice. I'm going to want my tiles to be a little bit bigger though. So here we'll double this. We'll have these. Cool. So we've got this cool class that will now generate this image. Well, what are we going to do with it? Well, what we need to do is to make it give logical meaning in the context of our program to each of these tiles. And the way I'm going to do that, so that I can later on integrate it with the other parts of this tutorial, is I'm going to create a node class. So each tile is going to be a node, and I'm going to create a grid class that is a grid of nodes. And that's going to be like a logical representation of this terrain. So let's go ahead. We'll add a new class. This is the node class. and it doesn't extend from anything.